Greetings folks and welcome to the first Electromaker show of 2024. If you're just joining us, this is a weekly show where we talk about the best things in the world of maker and embedded culture, whether it's new products you can buy or amazing projects people have made, and we also give a lot of things away. In fact, just before our Christmas break, we started a competition to win this. This is the Blues starter kit, which encompasses a cellular and Wi-Fi connectivity device, which is amazing, one of the easiest ones I've ever used, and an STM32 based feather footprinted development board on a nice baseboard. We'll be announcing the winner of that and also starting a new competition for an ESP32 based development board, which is our product of the week. More on that when we get to it. And this show is also going to cover just a handful of the amazing products and things that I have seen and wished I could talk about over the small Christmas break that we took. So we have quite a lot to get through today. So as always, less waffling up top, more show. Now, to start this week's show, it's been a while since we checked, does it run Doom? I mean, the answer is almost invariably yes. In fact, before we go any further, we aren't here to talk about whether this Verifone card machine can play Doom, but I do love the way you opened the door. But no, what we are talking about today is the Sparkfun Thing Plus Matter MGM240p, because does it run Doom? Well, absolutely it does. And in fact, if you look on the Silicon Labs blog, there is a fantastic article talking about exactly that. And this is a fantastic read in and of itself. It talks about exactly how they've done it. But just to give you the sort of Cliff Notes idea, this is not just Doom running on a Silicon Labs part. And just in case you're wondering, we talked in the past about the EFR32 MG24 series of chips. That's Silicon Labs' kind of flagship connectivity, does everything microcontroller set of chips. We've even given them away on the show. That is what's running under the hood here on the Thing Plus Matter. And yes, absolutely, it does run Doom perfectly in a higher resolution than the original Doom with sound, and it incorporates multiplayer over Bluetooth Low Energy, which is amazing. Now, as you're seeing, this blog does go into a fair bit of detail. It gives you the block diagram and gives you a few ideas as to exactly how they put it all together. It also shows how all of the bits fit together too. And this is truly a portable. As you can see, there's a battery power, there's a battery management system and all this kind of stuff on board too. But that is not all. You'll notice that there's two links in the description of this video to this project, and that is because not only is the Silicon Labs blog right here, there is the nexthack.com write-up of it as well. These are the same folks that did it. They're the guys that made it. And you may recognize these the name of these guys because we talked about them in the past. These are the same people who ported Doom to an nRF52840 dongle, one of those little USB Bluetooth Low Energy dongles that you can use for testing BLE devices. You can tell I'm a little excited and drank a little bit too much coffee because I'm tripping all over my words here. Now, I will leave it up to you to really dive in and find all of the awesome things about this. I don't have time to go into all of it. There's a few design decisions that I think are really nice here. I can't remember which one of the two blogs, or maybe it's both, but they mentioned the fact that they could have used a single 16 megabyte SPI flash chip, but they decided to use two, because you still get the 16 megabytes of storage, but you get twice the throughput for loading the WADs. And there's a micro SD card for loading said WADs onto it. I'm not sure if you could load the new sigil expansions onto it. I think they're probably a little bit large. But what an exciting time it is, by the way, that Doom's 30th anniversary has just come out and we're getting fresh Doom content from John Romero. It's kind of amazing. Anyway, yeah, I could chat about this all day. I am going to not. But in the description of the video here are links to both the Silicon Labs blog and the Sparkfun blog as well. I'll also link to our shop page for the Thing Plus Matter if you'd like to get this development board. It is a fairly cheap development board, and it was one that I was not aware of until I read this write-up about the Doom thing. And as always, I'll try not to labor the fact, but if you do want to support this show, shopping at our shop is the best way to do so. We don't run adverts. We do sell awesome things like this. Anyway, if you'd like to find out more, there will, as always, be links in the description. Recently, I have been researching clusters for a secret project, and I came across something from last summer that I missed, that I can't believe I didn't cover on the show, and that is the Pico Cray. This is a completely from-scratch DIY cluster using Raspberry Pi Picos. And you might wonder, well, why would you do that? It's not a bad question, actually. Ben Everett, the guy who wrote this up on the Raspberry Pi blog, mentioned specifically there's a number of things not going for it for easy clustering. It doesn't run Linux, it has no Ethernet interface or an easy access to the IP stack outside of the wireless version of it. But as you can see, these are Raspberry Pi Picos, full stop, not Pico Ws. And it says also it isn't really that powerful compared to, say, a Raspberry Pi 4, although ARM Cortex M0 Plus chips are incredibly powerful for what they can do depending on which direction you are looking, I suppose. However, the fact that it doesn't do any of these things means that making a cluster out of them will be difficult, and difficult is interesting. And what came next is essentially cluster by first principles. Ben decided to use I2C as his communication protocol, and also decided to use hardware as the way to designate which is the host, which is the controller, and which ones are the processors in the cluster. That way you only need to write one piece of code, one piece of firmware for all of the Picos, and that way you can extend the cluster after the fact. So how does having the same firmware on each Pico work in practice? Well, this image gives you a big clue. They all have one of the GPIOs pulled up, but only one of them has that GPIO attached to ground. So on boot up, it knows it is the controller. The rest of them are processing nodes that will speak to the controller via the I2C bus, but they all need their own I2C address so the controller knows exactly which one it's speaking to. And the way he does this is also really clever. He goes into it in much more detail in the article. If you read the way he says it, it makes a lot more sense. But if I was to say there's one line which is held high while it's assigning an address to one of the Picos, so that none of the other ones try and speak over the I2C bus during that time. When it's finished assigning an I2C bus to one of them, all of them go back to waiting a random amount of time to get an I2C address, and whenever it does it again, it holds it high and they stop doing it. It just stops crosstalk on the bus, which is, again, a first principles thing, but it's really interesting to see someone implementing this from scratch. He goes on to calculate the Mandelbrot set and make a really quite nice case for it in a custom PCB as well, including these wonderful vertical USB plugs you can see. Everything about this just really appeals to me, and I have no idea how I managed to miss it at the time, but you can find a link to this in the description of this video, and if you're a subscriber to the Hackspace magazine, you probably read it in the magazine, but just in case you didn't know, Hackspace and the Magpie magazine both put their articles online for free sometime after the print articles have gone out. I have the Magpie physical magazine delivered to my house, but even if I didn't, I know I can read it, and in fact I used to read it for free because they released them all as PDFs after the fact, just in case you weren't aware. Now, throughout 2023, we had a contest called Electromaker of the Month. Everyone who put a project up on our project hub was eligible to win, and we had a panel of judges that went through every project in the hub every month to choose 3 winners. And those 3 winners won cash prizes. The first winning $150, the second winning $100, and the third winning $50, and of course a nice big pile of swag, because everyone loves t-shirts and things like that. It's been really fun to see that, and we had a whole year of amazing projects, and it's time to announce the final winners of the year, which are our December 2023 winners. However, it is also my absolute pleasure to say that we will be continuing this throughout 2024. We have a new sponsor in Qoitech, and we'll be talking about the new contest and Qoitech more in just a moment. But before we do, let's look at the winners from the end of 2023. Before we look at the winners for December 2023, I would like to quickly thank Mouser, our sponsor throughout 2023, for their support for Electromaker of the Month. We give a nice tidy pile of swag and a certificate to all of our winners, and while these things are very, very lovely, it is through Mouser's generous support that we were able to also offer cash prizes. So thank you, Mouser. Now, there is a catch-all blog here that covers all 3 of the winners if you just want to have a brief rundown of what they were. I'm going to go through them in a tiny bit more detail, however. So, in first place and winning $150 and a big pile of swag is FarmGuard by Dark Sam. So, what is FarmGuard? Well, in short, this is an AI project that uses cellular IoT in order to recognize animals on a farm. Not necessarily recognize the animals you want in the farm, more recognizing the animals you don't want to come near your cattle and see them from a distance. Now, this is a prototype project. It is a proof of concept, but it is a fascinating one. So the idea here is that you have a single board computer equipped with a camera specifically designed for edge AI detection of objects or things, in this case, wild animals. So that's what the vision sensor and Raspberry Pi are doing in this block diagram right here. That information is being classified on the edge, and then the information from it is being sent to the cloud via a Blues note card. Now, I've waxed lyrical enough about how much I love the Blues note card. I think I've even done it within this show, so I'll leave it at that. It then gets sent to NoteHub, which is Blues's cloud platform for gathering data. And from there, it is passed on to Twilio, which is a call and messaging service that works through the internet, as I'm sure you are aware, and it will send an SMS to your phone. So in short, if you want to cut out all of the in-between stuff, if the vision sensor sees an animal that shouldn't be on your farmland, you get a message on your phone and you can react immediately. I highly recommend looking through the write-up, which takes you through all of the hardware used, including this beautiful Note Carrier Pi. This is a hat for the Blues note cards to fit it on top of a Raspberry Pi, including how to set up the cloud aspects of it and all the local software aspects of it, and also how they trained their AI model. Because you can't necessarily get actual images of animals in the wild very easily, but there's a huge amount of images online that you can use to classify it. Now, is this perfect? Could this work in a commercial setting? Not necessarily yet, but that's the idea of a proof of concept. If there is is enough commercial need for this, you tend to go from sort of proof of concept to something that works fairly well quite quickly. It's just a question of demand, and I can't help but think that with the amount of money in livestock, it's something that would probably be get quite a bit of interest if it was a commercial product. But then again, I'm not someone who knows how to make money or make products, so I have no idea what I'm talking about. So yes, the write-up is fantastic, and our judges were particularly impressed with the project's seamless integration of hardware and software, its intuitive alert system, and the potential impact on the future of farming. But yes, Dark Sam, this is a wonderful proof of concept. Congratulations. Our judges loved it, and I loved it. I tend to sort of guess a little bit which ones might win Electromaker of the Month, because as I've mentioned several times, this is thankfully separate from me. I get to just enjoy projects on Electromaker without worrying about people thinking I am choosing who wins money and stuff. It's not really my thing. But I kind of guess this one might do well. And you have won $150 and are the final first place winner of Electromaker of the Month for 2023. In second place, winning $100, is the Package Handling Assurance System by Nekhil Ravi. Now, we've talked a lot about asset trackers over the years on this show. It's a big thing in IoT. Now that you can have tracking systems that use such low amounts of power and are cheap enough to strap to packages, it's something that's becoming a little bit more common. But this is taking it a little bit further. This is actually checking that assuring that a package is handled the way that you want it to be. So, what do you need to check that a package is being handled well? You need some way of knowing if it is being handled poorly, some way of measuring its movement, for example. And that's where the core of this project comes in, the Arduino Nano 33 BLE Sense Rev 2. We talked fairly recently on Electromaker about the difference between all the different Arduino Nano variants, and this is one of my favorites because it has exactly the same kind of thing in it as the Xiao NRF 52840 Sense board. Both of them have an inertial measurement unit in it, and both of them have Nordic's NRF 52840 BLE chip in it. So if you were just working with Bluetooth Low Energy, if you needed to assure a package was being handled correctly within one building, you could do it just on this development board. Because it has the inertial measurement unit on it, you can use Edge AI in order to train the board to know when it has been dropped or tipped in a way that it shouldn't have been, and then it can communicate via Bluetooth Low Energy. However, this is less useful when you want that package to be actually sent somewhere. For that, you need some kind of GPS module to see where it is, and some kind of way of talking to the cloud. So, unsurprisingly, that's me just knocking everything off my desk, it has a GPS module from Adafruit, and once again a Blues note card, just because they're so easy to use in terms of sending data to the cloud. Again, I could start talking about Blues again, not going to. I do that somewhere else in this episode. Yes, so combining these things together is a perfect way to set up asset tracking. However, what really makes it work here, what really gives it the key, is the fact that you can run Edge AI very easily on the Arduino Nano. And the days of Edge AI being very, very difficult to achieve are over. With Edge Impulse, you can use their browser-based system for doing pretty much everything. In this particular demo, they're using the command line interface as well, and they're using it to train a model based on various ways that this box can be dropped. You see they've strapped a breadboard with the Nano on it to a box so that they can move the box around in different ways and say this is acceptable, this is not acceptable, and build a model based on those parameters. But as always, Electromaker contests are a documentation contest, and the documentation is fantastic. It goes through absolutely everything you need to recreate this if you want. Even if you wanted to do something somewhat different, but that still involved using Edge AI in an Arduino Nano, for example, this would be invaluable. This is a great starting point. It works sort of as a bit of a tutorial for cellular Edge AI in general, but also it has a very specific end route as well. So if you are interested in finding out a bit more about it, there will of course be a link to this in the description. Our judges really loved this as well because they were captivated by the system's ability to transform package handling into a monitored, secure process, which is exactly what it is. Asset tracking is changing, and it's so nice to see these prototype projects that are doing it. Third prize this month, winning $50 and a pile of Electromaker swag, is Buck Nalla with the cellular bilge alarm monitoring system for a boat, which once again uses the Blues, formerly Blues wireless kit, uses a Blues note card for communication, which is, it's funny, I think all three projects use Blues this month, but all three of them are cellular projects, so I guess that's why. The thing about this project that I like is that rather than it being a microcontroller project that could be applied to something in real life, as it were, this is a real life problem that you're putting a microcontroller to. It's sort of the two kinds of projects that work with microcontrollers. You either have something that you want to program and have an idea for how it could be used, or you have a problem that you want solved. So you're using a microcontroller, or in this case, a microcontroller development board and a cellular Wi-Fi system to solve it. And the problem here isn't necessarily a problem, it's more really being sure that your boat doesn't sink. But no, But no, what I'm talking about here is automatic bilge pumps that exist in various boats. There are various different kinds of it. The ones that I have physically seen with my eyes all work the same way. You have a bilge pump at the bottom, and at a certain height in the boat, you have a switch which has a float inside it. And when the water goes past that switch, the float goes up, completes the circuit, and turns the bilge pump on. It's a system that shouldn't be able to fail in theory, but all of those systems that mechanically shouldn't fail in theory, they all fail from time to time. The idea here is that you want to know when the bilge pump is going, and also you want to know if the water level has reached an even higher level than you would expect. That's why there's a low water switch in this diagram and a high water switch. When it reaches the low water switch, it should turn the bilge pump on. However, if it doesn't, and it reaches the high water switch, you're going to want to know about that, and that's where the Blues kit comes in. This is the same Blues starter kit I've talked about several times, working on a battery with an octocoupler that is connected to the float switch. If that float switch switches, it will send a message to the Blues note card, which will send a message to the cloud. Now, before we look at what the judges had to say about this project, there's one other thing I want to mention. I spoke recently about the Zephyr RTOS, which is a little bit more than an RTOS. It's more like a Zephyr framework for embedded systems, and it kind of blew my mind how powerful it is and also how incredibly difficult it is to get started with. I'm still working on that in the background, and there's going to be more Zephyr stuff from me coming very soon. I'm working on a thing. But this uses Zephyr, and it's quite interesting how well integrated Zephyr is into this Blues system already. Essentially, it's an STM32L4 board, and that's thoroughly supported by Zephyr already, so you can just use it as that, but then you can still use the same the same note card library that they give you from Blues. I could have said that much better. And once again, this is just creating a JSON request that you send to the note card, and it will send it to the note hub. And this is once again connecting to Twilio, which means that if the high water of the boat reaches a certain point, you will get a text message immediately, and you can run to the docks before your boat sinks. I don't know why I laugh so much when I say your boat sinks. It's not funny. It's not funny when boats sink, but there's something, very funny about that to me. Anyway, our judges were impressed by the project's ability to bring peace of mind to boat owners. Not only does it help prevent disasters, it provides assurance. The cellular bilge alarm monitoring system uses the power of technology to enhance safety and security in the nautical world. Absolutely. So, congratulations, Bucknell. You win the third prize, which is $50 in cash, and the Electromaker swag. And of course, all of you win the vaunted Electromaker of the Month certificate, and you win the last ones of 2023. But that is not the end. We have a new Electromaker of the Month contest running throughout 2024, I'm very, very happy to announce. Yes, Electromaker of the Month will be continuing throughout 2024 thanks to the generous support of our new sponsor, Qoitech. Thank you, Qoitech, for sponsoring the innovation of our community. Thank you for making it possible for us to celebrate the makers that put the wonderful things up on our project hub. And a lot of this is going to be very similar to last year. The first prize is still going to be $150 and a pile of swag, with second prize being $100 and third prize being $50, also getting a pile of swag and the vaunted Electromaker certificate. The swag pile has been somewhat improved this year. We have some Qoitech swag alongside our Electromaker swag, which is going to be very nice indeed. Let's just take a quick moment to talk about Qoitech as well. Qoitech's hardware and software can help you make energy profiling decisions for your project, if I had to put it in a brief sentence. Their hardware and software together can even emulate batteries so that if you're working with battery life, you can get the most out of your product, but you can also very carefully profile what every single step of your embedded design does. We're going to go into it in more detail in a future show. This isn't really a Qoitech section. That I just want to announce them as the new sponsor of Electromaker of the Month. But just quickly before we go on, the Otti Ace Pro is a box that, as mentioned, allows you to do all of that profiling. The software itself allows you to get into a really fine-grained detail as to how your power usage is working. And as previously mentioned, they have an add-on that allows you to emulate how batteries will react to your project, which is incredible. They also have an automation toolbox, which I find fascinating. This is one of the bits that I'd be really interested to work with, because essentially it turns, as it says, an automation toolbox makes Otti boxes programmable. You can control them with the built-in TCP server from any language or system that supports communication over TCP sockets using a JSON-based API, which for me makes things so much easier because I like my own way of working. I don't mind using proprietary things here and there, but the idea that I could just talk to an Otti box over TCP and get all of this information back is something that appeals to me. But it is one of many, many things that Qoitech offer. Anyway, as mentioned, we're going to talk about Qoitech more in the future, so let's not get too distracted. Electromaker of the Month will be continuing. If you are interested in finding out more, I will be linking this new blog in the description of the video too. You can find out how you can enter Electromaker of the Month. If this is the first time you're hearing of it, you just need a free Electromaker account. If you click Join Us up in the top corner, you can create an account in seconds. It's completely free, and then you can add things to our community hub by going to the project hub and clicking Upload Your Projects. If you'd like a bit of guidance as to how to do that as well, we even have a guide linked here in the article as well, along with a video showing some of the old winners of Electromaker of the Month from August last year, I think, so you can get an idea about some of the projects that have won, although we just talked about those as well, didn't we? But yes, I'm very, very happy to say that we will be continuing this project throughout 2024. It's a really wonderful thing to know that not only do I get to chat about wonderful projects that people make, but those people are getting celebrated and indeed remunerated for their innovation. And as I've said so many times, the complexity of some of these projects is incredible, but that's not what we are judging here. We are judging the documentation of a project, and even if you're working on something which other people might say is simple or whatever, if you document it thoroughly and are doing it in a way that is interesting, if you're maybe putting a new spin on an old idea, you are just as likely to win as someone who is doing something incredibly complex on the cutting edge of embedded tech. I really want to stress that. This is not a top of the tree, the best engineer wins. We really are interested in people who are passionately sharing what they make, and that's exactly why I'm so happy that we're going to be doing it for the rest of the year. Now, before our Christmas break, we started a contest to win one of these. This is the Blues Starter Kit, and it is a cellular and Wi-Fi kit, essentially. The star of the show here is the note card. They also have their own STM32-based dev board, and this big thing is a base board. I'm going to try not to spend too much time talking about it yet again here, because A, I've talked about it a lot, and B, there's a 2,000-word review written by me in the description just there, where you can find out everything you need to know about this. But the kind of one-sentence pitch for it would be, the note card can talk to any host MCU or computer via UART or SPI or I2C using JSON commands, and it can also speak to the Note Hub, which is Blues' own cloud. It's one of those off-the-internet solutions, and it's incredibly easy to use from the top to the bottom. I am not an engineer, and yet I got something up and running with this within minutes, and unless you really want to go into the weeds and create your entire stack from scratch, I can't see any reason why you wouldn't want to use something like this. I said I wasn't going to gush about Blues again, and I did. But seriously, I'm going to be writing another thing about Blues just off my own back and putting it in the Electromaker project section, because I've got a bunch of ideas of what you could do with it. It's really cool. Anyway, without any further ado, we started a contest for it, and all Electromaker contests are essentially the same. We'll be starting another one today, a little bit later in the show. Anyone can enter them who is subscribed to the channel. You just have to leave a relevant hashtag and say what you're going to win, and we choose each winner at random. And so, the winner for the Blues starter kit is YouTube user Bober1777, who says, I'd love to integrate the note card into my bike tracker project. Was planning on using my SimCom module, but AT commands have been a nightmare in the past. Plus, having Wi-Fi integration also opens it up to other features like dumping data when home without having to connect it to a smartphone, with the hashtag note card, which is the one I asked you to leave. Congratulations, Bober. I'd be really interested to hear more about your bike tracker project. Consider writing it up and putting it on the Electromaker Project Hub. Yes, thank you to everyone who entered these contests. And if you are interested in finding out more about the Blues note card and the starter kit and all that kind of stuff, like I said, I wrote a big review of it. This isn't one of the things where I'm saying buy it from us. I don't even know if we stock it. Yeah, everything I've learned about Blues so far and the way that they do things impresses me a lot. Now, that's not the only contest that we have in this episode. Yes, Robin is back with another Product of the Week video, which means, well, we're going to be giving that Product of the Week away, and it is the Firebeetle 2, which is an ESP32E based development board. Now, as to why you'd want this specific development board compared to the many others that have ESP32 chips on it, I'll leave up to Robin to explain. You'll find a link to that video in the description. As always, Robin can go into a level of detail that I find difficult to, because he's an engineer and he literally understands what he's talking about, whereas I have to fact check pretty much most things I say, and I still get them wrong. But no, a couple of things that from me looking at this board, the things that jump out to me are the general display interface on it. It has that interface you can see it was in the top corner of the video. Just under the chip, there's a place you can attach a variety of different screens to, and it supports charging. It has battery management on it, and it supports charging that battery via its USB port, which is a USB Type-C port. And one of the things that both me and Robin share is a conviction that all modern development boards should have USB Type-C on board. It is just the standard now. Anyway, this is the giveaway that we're going to be starting, and if you would like a chance to win the Firebeetle 2, it's very simple to enter. Yes, all contests here at Electromaker run more or less the same way. All you need to do is make sure that you are a subscriber to our YouTube channel, and that's pretty much the only barrier to entry. Leave a comment on this video saying what you would do, what's your project, what do you think of when you see the Firebeetle 2 development board, where does it fit into your hobby or your idea for a business or anything like that, what would you use it for? And then leave the hashtag Firebeetle2, no spaces, just Firebeetle2, and we will be picking a winner on next week's show at random. Yeah, this is a really nice one to give away because ESP32 boards are so ubiquitous at this stage that I'm sure everyone will have a nice idea for what they could do with it. This one does seem to be a particularly nice one. We'll be talking about it again next week, but for now, good luck. We're going to move on now to a flashlight door lock, which on the surface does not seem secure at all, but it's actually a really wonderful idea that combines a smartphone app that can send data via the flashlight of the phone, which in and of itself is something quite amazing, which we'll discuss in a moment, and then the lock system, which uses an Arduino with an LDR to unlock the door based on the timing of a flash. Now, this is a project by Mirko Pavlesky, also known as Mirsa MK on Hackaday, and it's on the Hackaday blog. Christina Panos has done a fantastic job writing it up, and I'll leave a link to this in the description because it's where I found it, but the first link is to his write-up of it as well. So this is an Arduino-powered lock, and it has a solenoid inside, as you would imagine. It also has a light-dependent resistor and a couple of other bits and pieces, but the main thing here is the light-dependent resistor that waits for precisely the right amount of light from the smartphone light from the light. And at first, you might think that sounds horrifically insecure because you could just flash the flashlight at it at random until you get it right. But we're talking millisecond precision here. This app, which is the work of Himanshu, he put his full name somewhere here, Himanshu Sharma's Li-Fi project, which we'll come on to in a minute, generates millisecond precision light from a smartphone light. Light from a light. I'm going to have to get used to saying that. And if you think about the number of permutations, that's quite a lot. I mean, even if you just kept this under 10 seconds worth of light, 9,999 milliseconds, you'd have 10,000 permutations, but you can't do them all one after the other. So you'd have to start with almost 10 full seconds of the light being on before you could say, okay, it's not 9,999 milliseconds, let's try 9,998 milliseconds and wait a further almost 10 seconds. It's actually a surprisingly secure way of doing it. Now, as to the app side of it, what's happening here is there is a passcode stored in the app, and it's only one of the correct passcodes, and you can then type it in and click send, and if you have the right passcode in the app and the right light comes out of the app, then the door will open. I don't think I explained that well, but I think you know what I mean. Now, as previously mentioned, this is the work of Mirko Pavlesky, who has a YouTube channel. And what you're seeing here is the lock in action. So in the app is the word hello. He sends the word hello, which is through the Li-Fi app, which we will come on to in a moment. And as you saw, the door opened. The next thing he does is he tries typing in a different password and shining the light at it, and that does not work. Oh yeah, he's showing how you can try randomly shining the torch at it. Now, the video goes through exactly how it fits together, how you can do it all. In fact, Mirko's channel is fantastic. You should definitely go and subscribe to him. And if you'd like to know more about the project behind it as well, which is Li-Fi, the GitHub is linked out of the project. So the route you follow is to go to the link in the description, go to the link here, which is to the actual write-up of it, and you can see the circuit diagram here. And also head through to the Li-Fi GitHub page, which is just here. And that will take you to the app side of it. And the app was already pre-written. This is, as previously mentioned, it's Himanshu Sharma's project, which is equally fascinating. This is a way of sending data via light. I did not need to make that sentence as long as it was. So again, here he has the Li-Fi app open. He's typing hi, he's clicking send. And it is showing up on the screen just here, which is a wonderful thing in and of itself, and a story for another time, maybe one that we will come back to, because there's a few interesting projects that transmit data and things like sound via light, and I think I'd quite like to revisit that at some point. But But yes, another thing that's quite nice about this particular project is that despite it looking very professional, the bill of materials is very cheap. It uses an Arduino Nano with a MOSFET attached to a solenoid with a 12-volt DC input and a little breakout board there with the LDR, although of course you could just rig that up yourself, and a little buzzer too in order to hear the sound of the door opening and closing. Oh, and of course a couple of LEDs for on and off. It's just a very nice build for an interesting concept of a project and a nice way of reusing the Li-Fi app. And I feel like this combination of things could be used for many other things, but I'm blanking on that right now. If you have any ideas, I would love to hear them in the comment section of this video below. Finally this week, I wanted to point out a really handy little hack that I discovered just before Christmas. I say discovered, I read it on Hackaday just like the last thing. But it's to do with the 80 mega and 80 tiny chips. And that is, you can take power readings of the circuit using the internal ADC on them. And it's just a really fascinating idea, and I wanted to tag it onto the end of the show. So as you're seeing, this is again Hackaday, a blog by Donald Papp on December the 21st. It's one of the things I was reading just before Christmas. And the CPU Vault library is an Arduino library based on a manual, a white paper from Microchip, an application note. Both of which you can find here, and just I'm going to very quickly whip through this because we're out of time for the show, really. I would like to point out just one last time in the show, if you are thinking of trying to do something like this, or you want to get an Arduino something or other, just pointing out that we do stock pretty much everything from Arduino, and right now we have an amazing amount of stock of pretty much everything. So if you are thinking of getting something, it's the best way you can support us. We don't run ads. Now, Arduino, battery power. If you are running an 80 mega 328P chip, for example, on battery power, as you may well be if you have an Arduino Uno, you might want to know exactly how much power that battery has left before you need to, say, change it or charge it or something like that. And you can do that using the internal ADC without any external parts whatsoever. And it does it in quite a novel way. And I don't think I'm going to be able to say it quite as briefly as Donald sums up in this article, so let's just look at the way he puts it here. So there are other ways to do it, but what happens in this method is one selects VBG, a fixed internal voltage reference that is temperature independent, as Vin, and selects VCC as the ADC's voltage reference. This is essentially backwards from how the ADC is normally used, but it requires no external hookup and is only a bit of calculation away from determining VCC in millivolts. So what does that look like in code? Well, this is the GitHub page linked from that page, and this is the CPU voltage library. This is an Arduino library. You can add it to the Arduino IDE or Platform IO or whatever you're using the normal way. And let's just jump straight down to the code use. So you include the library, setting up the serial so we can check it. And this is one of the methods from the library. This is read VCC, and this will read the power in the circuit, and it'll divide it by 1,000 to give it an easier sort of way of reading it. And you can print out the voltage there. You can also read the percentage of the battery. The percentage is arbitrary, really. In this case, 5,000 is 100% and 0 is 0%, which isn't that useful necessarily, but is getting there. But the very next thing is exactly what you're looking for, especially if you're using, say, a lithium battery. You can also specify both lower and upper ranges to be considered what is 0% and what is 100%, which is very useful for battery-powered projects. And this is exactly what you're seeing here. Read percent with 2,900 millivolts, or 2.9 volts being the lower side, and 4,700 volts being the higher side. If you have a lithium battery and you don't want it to get too low and you don't have a battery management system in place, you can have it so that it will start flashing when it gets down to a certain low voltage. Forgot the word for voltage. Been a long day. And this is exactly the code that you would use to do that. So what's the percentage you would want to know about before a battery gets too low? In this case, they're saying 70%. And then they have a bool, which is needs charging, which is changed via this low percentage number. Is it lower than the percent that's already there? Set up a pin to blink if that is the case, and then that pin will be an output. And you can write to that pin the needs charging bool, which is a very simple way of doing it, and as mentioned before, uses no external parts whatsoever. Just a really nice thing. So if you are interested in finding out more about it, I will leave a link to it in the description. As always, there's a very nice short write-up of it here, and if you are interested in reading a bit more about it, the actual application note from Microchip is here too, which goes into all of the gory details, but it's not actually all that complicated. I read it and my head did not start hurting, so take it from a non-engineer that it is definitely readable to anyone that is interested in it. But yes, if you are using something like like this in a project you have already, I would love to hear about it. As someone who from time to time gets very obsessed with trying to make little battery powered projects just to see if I can, I'm always interested to hear the little hacks and ways around people find the inevitable problems with working with battery systems where everything runs out and you don't want lithium batteries to get too low and all of that good stuff. That has been our show for this week. Thank you so much for joining me for our first show of 2024, and I'm very excited for what's coming this year. As well as the Electromaker show, I'm taking on a couple of other projects which allow me to actually get my hands on and do more things and make more things, which I'm very happy about. And just a quick reminder as well, if you see any adverts on our YouTube videos, that money is not going to us. We have not turned monetization on this or any platform. The way that we make all of the money for this show is directly from the Electromaker shop. So if you're thinking of trying any one of the things you see in this show or just want to get a hobby kit for someone, do consider going to electromaker.io/shop. That is the best way you can support us. Anyway, I shall be returning next week with a whole host of other amazing things to look at. And of course, all of our regular series will be returning this year as well. The Electromaker of the Month, as I mentioned, will also be returning this year. So you can win prizes each month by simply putting your project on our website. But for now, I wish you all a safe, fun, and creative week, and I'll see you soon.